Right. So, welcome back to our journey of developing a simple mechatronics model for a rod attached to a motor. Since lecture 2, we have been discussing methods of implementing this model using MathWorks products. And throughout the lectures, the implementation of the model has gotten kind of simpler. It has gotten less abstract, and now it closely resembles what we see in actual life. So in lecture 5, this is what we obtain at the end of the lecture. We are using Simscape blocks and Simulink blocks as well. The rod and the revolute joint has now been implemented using Simscape blocks. So they are modeled as what's seen in the physical world. The effects of gravity and the effects of the permanent magnet DC motor are modeled through equations which are implemented using Simulink blocks. Now in this lecture we'll take it a bit further in making it less abstract as well. So today we'll replace these Simulink blocks for the PMB DC motor with the Simscape block offered by MathWorks. So I'll bring in the block first. You can either search for it on the canvas or browse the library browser and find it at the relevant location. So there are multiple options available, brushed version and the brushless one. So I have brought in the Simscape block for the brushed DC motor. If you are not sure, then you can right click on it and view the help. Sorry. Can do that if you are unsure about how to connect the ports of this particular or any Simscape block. If you are unsure about the ports and the connections, then you can bring up the help in this manner, or upon double clicking it, the prompts also carry out some advices on how to connect the blocks and to which upstream and downstream blocks it should be connected to. Right, so that's it with regards to getting some information about these blocks. If you aren't familiar or if you have forgotten how to use these blocks, so let's move on to modifying what we have, modifying what we had in lecture 5 and replacing the Simulink expression with a Simscape block. So first I'll save it into a new file. So what really goes on inside of these Simscape blocks is uh, the effects of the motor, electromagnetic, mechanical, and thermal. They are represented as equations or expressions, and Simulink blocks are implemented inside of these Simscape blocks. So these aren't visible to us, but if you were wondering what's behind the black box, then what I just described now is what's going on. So we'll start out by removing what we don't need. We are replacing this section since this is what these blocks are what describe the PMB DC motor previously. Replacing these ones, so I'll remove them first. Will not be removing this combination of blocks since this is what models the effects of gravity, and in this particular lecture we are not replacing these blocks. It's mainly because I haven't seen an option to do so in Simscape foundational library. Right? So we'll keeping this set as it is, but I'll remove the rest as well to declutterize the canvas before I make modifications. I'll remove the connections as well, since I'll be adding some new blocks and ports. I will remove these connections so that I'll be starting out afresh. So to incorporate the effects of gravity, I'll be needing an ideal torque source at some point. But this would not be what I'll be connecting first. I'll start out by connecting the inertia to the motor. So the motor has two sides to it, the electrical side and the mechanical side. The blue colored ones are electrical, and of course the green color is mechanical. So let's finish the mechanical side first. So the motor has a case and the rotor, and at least one of them need to be fixed and other will rotate relative to the one which is fixed. To fix either the case or the rotor, you need to connect it to a rotary inertia, rotary mechanical rotary reference, and I'll be connecting the C port to it, since that's that's kind of a standard that we have followed so far. And upon connecting the inertia to the other side, Mathematics will understand that the rotating side or the rotating shaft, the motor will be connected to the inertia. And I will have to specify the value of the inertia. But since I began with what we left in lecture 5, it's already been specified. But you have to specify it yourself if you are beginning anew. So that's kind of it with regards to coupling the rod to the motor. We will be needing to connect the ideal rotational motion sensor at some point as well, since our Simulink block combination for the effect of gravity requires the angle as an input. We'll be needing the rotation sensor to figure out what the angle is and feed it into this section. But we'll connect, yeah, we can connect it now. So we'll follow our standard of connecting all the C ports and R ports together. So it's kind of a like a rule of thumb when it comes to relatively simple mechatronic systems, and it will serve you well if the system is simple one like this. But however, if you proceed into more complex ones, then you have to refer to the documentation and think quite well prior to making the connections. So in our case, my rule of thumb of connecting the C ports and R ports together works quite well. So we'll be needing to connect. So this has two output ports, one for the angle and one for the angular velocity. Let's assume that I have forgotten the units and which ports output which signal. Then I can just click on it, check out the ports. So W will be for angular velocity and A will be for angular displacement. So angle to simply put. I can't make the connection yet, and I hope you remember why. What I am dragging right now is a Simscape signal, and these cannot be converted into Simulink blocks. I will be needing a Simscape to Simulink converter to do that. So now the angle has been read and fed into the block set, which models the effect of gravity. And I'll be needing to connect the effect of gravity back into our system. So if we take a look at the block for the motor, if C is fixed,